I'm going to begin. I keep on schedule. I'm probably already starting a few minutes late. Okay, today we're going to be talking, the title of the session is Security Solutions for Firmware Integrity, Hardware Licensing, and Connected Licensing. However, I'd like to change it. I'm going to really be focusing more on security for connected environments. In that vein, I'm really going to be focusing on three major points during this session. I only have 30 minutes. I could talk for 30 minutes on each one of my slides, probably, at most. So I'm going to go at a cursory, very high level. And please, during the breakouts or after the session, we can talk in depth about anything. So really, the agenda I'm going to be talking about first is really focusing on the security problem in a connected world. What are those security concerns? Then I'm going to break down about how we go about it in two different ways. One, how do we secure the client or the device? And two, how are we going to secure the ecosystem around it? How do you communicate? How do you identify and authorize what's happening in that ecosystem? So first, looking at security, the security problem in a connected world, I'm really going to break that down into three different security concerns, security areas. The first security area is the security of the software that's actually running on your device. How do we secure that? The second is about the security of the identity and communications. How does this device or client talk securely? How do you identify them securely? And finally, how do you authorize that client or device to do what you want to do and not do what you don't want to do? So that's the scope of the presentation. So if we start first with looking at how we secure software running on devices. Now, when we talk about devices or client, it can be a machine, it can be software running on a tablet, it can be on a desktop. We don't mind which way it is. So the first step of securing that software running is we actually have to care about the integrity of the device. Where is the software actually running? We want to make sure that there's no Trojan processes running on that application. The data that's on that device has not been compromised, it has not been modified. And really, we want this device to not be doing something that it shouldn't do. There was a recent article about how one happy guy in a neighborhood broke into his neighbor's IoT-connected refrigerator and created a spam bot, sending 10,000 spam emails a day using that refrigerator, right? Great, thanks. So we don't want somebody to take control of our device or our client software and really make it do something it won't. I'm going to talk about how we do that in the next session, just highlighting the problems. The next problem is when we talk about security in a connected world, it's not like 5 years ago where you buy a device, you sell the device, it's perpetual, it's sitting in an isolated environment, you never update it. Or if you do update it, you send a technician to do so. Life doesn't work like this anymore. Now in a connected environment, the software, you deliver the device as a vehicle of software value, right? And you want to update that software value over time. Maybe you want to start with a base feature set. You continue to invest, so you want to update and sell new features that you add to your product portfolio. So we really have to care about how software is going, installation, and updates to that client and device are happening. So we want to make sure that the installation package, it wasn't tampered. We want to make sure that the applications running there aren't tampered and that the software updates are coming from a trusted source. The most common vector of attacks against applications tend to be not from static analysis of applications, but of real-time analysis after an application's been running. That's kind of the weakest link it tends to be in the software application world. So when looking at the security of software running, we really have to understand that we want to prevent real-time analysis against what the device or application is doing as much as possible. Yeah?
Do you mean to say data in flight versus data at rest?
Sorry, data
in flight. Is it called data in flight for security?
In flight?
Yeah, in a sense, in motion. When it's going from...
Exactly. Not necessarily in motion, but loaded into the memory of the application. So not sitting resident in a binary format, right? PE format is a file on your desktop. So there's two different attack vectors, right? When the application is resident, It's a static, passive attack against that, right? You're trying to open up that application. You're trying to understand what are the import gates, what's the logic of the application. Maybe I want to reverse engineer and steal some IP from what this application is doing. That's one attack. The second level of attack is actually after you launch the application, right? The application's loaded in the memory of Windows. So now you have to protect this in running and executing environment, right? So those are kind of the two different vectors. So debugging, tracing are the typical attacks against an application running. The reason hackers will do this is they want to tamper, right? They want to tamper with the memory data. They want to tamper maybe to make it logical jump from one method to a different method that they've installed. And then, as I mentioned, IP theft, right? As the world is moving, more and more value and applications are being written in high-level languages. Okay, well, I put a lot of secret sauce. How do I protect that secret sauce? The last part, the last category of securing the software running in a connected environment is many of our customers have an open ecosystem. It's not just I have a device and I'm the only one providing software for it. I want third parties to add value to my ecosystem, to my platform. So, of course, security is only as strong as the weakest link. And if you're not securing those add-on applications, you open up a new attack vector against your device. You can control the device through an unsecured application. So how do we provide an environment or an ecosystem where those who are adding applications to your client or your device, we offer them the same level of security you yourself are using? And in addition to that, how do you authorize that, hey, I'm going to get paid before a third-party person puts their application on my device? I want to control that experience. So those are the security concerns of what the challenges are for software running on a device. These four things: the client device integrity, installation and software updates, preventing real-time software analysis, and third-party add-ons. Okay. Still in the scope of what is the problem domain that we're trying to solve, we want to think about the security of identities in communication. Why do we want to think about this? Well, there's three major reasons. When you have a connected environment, right, we're talking about a connected world here, the data that's coming back from a device is very important. And we want to trust that data. Why do we want to trust that data? Because we're using that data in 2 or 3 different ways. The first way we're using that data is usage data that we want to monetize on, right? We want to prepare a bill for our customers. Well, if erroneous data is being reported to us, maybe I'm billing them 10 times more than I should. I need to make sure that I can trust the data coming back from my clients. It's not a false client. Also, I want to use this data, maybe as Amy Connery had talked about earlier in IDC, people are monetizing the data itself. Now I want to repackage and sell this data. Well, if the data isn't good, how can I sell bad data? And the third is for business intelligence, right? The data that's running on these devices, on these sensors that are out there in the world, I'm gonna leverage that for continuing to build my product in a way that better fits my customer base. So I want that data to be valid. I don't want erroneous data there. The second concern is about data leakage, right? I don't want someone asking for the data shouldn't get the data, right? Only I should be the getter, capturer of that data. I don't want somebody who has another device to be able to read data from one device. I'm the only person who should be able to get that data. And lastly, data privacy. Now, when we talk about data privacy in the larger context, we really mean user privacy, right? End user privacy. What I talk about is when you're sending data to your application, maybe it's configuration data, maybe it's new algorithms, maybe it's a design file for how a machine should cut a piece of wood. Whatever data you're sending to that client, you only want that client to be able to decrypt that data, to use that data. That data should be meaningless to everyone else. So we want to make that data private to a very specific device that you identify. So that leads us to 2 basic things, right? How do I know who you are, who you say you are? How can I trust you? And who can talk to my client device? I want to control those things. So I'm going to talk about how we do that. And lastly, still in the scope of what are the challenges of our devices in a connected world, I like to think about authorizations. this is in two flavors. First is what can I do, right? From, as I said before, the first attack vector, the most common place of attack is when that application is launched and running. Well, if you don't have a valid license to use the application to begin with, do you even want the software to launch? Or do you even want the boot process to start? If you can't start the boot process, it makes it that much more difficult to create an attack. And then, are you authorized to use a certain feature? So we all use features, right, and feature packaging as our monetization strategy. So we want to make sure that when you introduce a new feature, when you develop and invest in building new features and bringing those to market, you have a way to monetize those. And the second part of authorizations is really in the device world and the machine world, what we see is, you step back 5 years, most of these machines were sold in a perpetual way, or devices sold in a perpetual way. You sell a device, and the only consistent revenue you're getting is from the servicing or the maintenance of those devices, right? That's your recurring revenue after you sell the perpetual device. So many of our customers actually use licensing to authorize who's allowed to service this machine, because they don't want that service technician to essentially quit and take all the clients with them and continue to service the machines or the devices. So we want to be able to license who's allowed to service or not service. And then lastly, are you allowed to update or modify a configuration? So again, what can this application or machine do? We have a customer who has a perfect example for this. Is we have a customer who is making milk cartons, right? And in milk cartons, you have to pasteurize it. So you don't want to put milk into unpasteurized machines. So this customer who's building milk carton machines that take milk carton, when they deploy their machines, what they struggle with is their customers, they want to be more profitable. They want to make more milk cartons per hour. So they speed up the machine. Well, once you start speeding up the machine, now the pasteurization process isn't getting enough time. Now you're creating a health concern. So who can modify that part of the configuration of this machine is very, very important, especially in certain industries, like medical or health. Okay, so those are the categories of what the scope of what we want to solve for the security problem in a connected world. So how do we do it? Again, I only have 30 minutes, so I'm kind of racing through my content. So first, we want to look at securing the client and device. So again, as I mentioned, we're not just talking about devices as machines, we're also talking devices as tablets, maybe a tablet to a machine, maybe it's a desktop, could be anything. So the first area we look at is copy protection. Why copy protection? Because when you talk about security, what do we care the most about? Revenue, right? This is what we're all here for. We want to make money. Well, if you can't secure the revenue, how do you secure the revenue? The most common area of securing the revenue is to prevent illegitimate free use. Now, there's two categories of kind of pirates in the world. The first category is those who are looking to hack your application and use it, and they'll never pay for it. So even if you secure it, you're never going to see increased revenue. So generally, those aren't the people we're targeting when we try to increase our security. What we really care about is preventing and capturing additional revenue from unintentional misuse, right? Somebody buys a version of your application for 10 users, let's say. A few years go by, user licenses have changed, and now they're using 50. They don't even know that they're overusing, right? They don't want to be out of compliance, but they're unintentionally misusing. The general industry statistic is if you can close unintentional misuse of your application, you essentially grow 20% of your revenue. That's a general concept. And also, copy protection helps you to protect brand, right? You don't want a version of your application to go out. Amy Connery talked about this earlier today, where she talked about customer experience, right? And that's what brand is about customer experience. One of her main points in the customer experience was IP protection. And I talked about that. And you think about, well, what does IP protection have to do with brand? What does it have to do with customer experience? Well, customer experience around brand is the concept of when you put an illegitimate copy of your application, most people are putting Trojans or malware into those applications. And as an IT team, you're deploying those applications in the field. You don't want to download the wrong version of the application, right? You don't want a knockoff. When you buy X software, you want X software. You don't want an illegitimate version of it. So how do we go about doing that? So it always starts with taking a trusted source, always. So here we have 4 different versions of trusted sources. We have the USB key with the smart card chip containing your cryptographic secrets. We have a chip form factor, as I mentioned earlier in the day, that can be embedded and soldered onto your boards. We have a software file, right? It's a software license that contains those cryptographic secrets. And we have the cloud-delivered licensing experience, which I think you've heard about already. So those are our trusted sources. And what we end up going about doing is we securely challenge them. So using a combination of cryptography, AES, RSA, ECC, asymmetric cryptography, we do strong challenge responses to make sure that, hey, this is a valid license. This application or device is real. One of the most important things, though, isn't just the challenge, is that we use a secure communication. We create a secure communication from your device to the trusted source. You need a secure communication channel. We do that using white box cryptography. Okay, the second thing about securing the client is we look at how do we secure authorizations. I think about this in feature-based licensing, right? All of us tend to want to sell our products, and we want allow access to an initial feature set. Well, sometimes that initial feature set's paid, sometimes it's free, and we incent people to upgrade to more valuable features. But when we talk about a connected world, the most important aspect of it is how do I upgrade it in the field, right? It's not a static box. I'm going to deliver this box, and I want to continue adding value and capturing new revenue from this device over time. Okay, so you have to allow it in the field. So how do you do it securely? So you create your license update, whatever that license update is, whatever format it's in, it doesn't matter, but you have to secure that update. We secure our updates by signing and encrypting them using asymmetric RSA keys. And then, of course, the whole concept of a trusted source is that when you decrypt and you validate that update, you're doing it inside the scope of your trusted source. You're not doing it outside and then applying an update. You want to do it within the boundaries of the secured environment. Next, we'd like to talk about reverse engineering protection. So again, this real-time analysis is really the biggest threat out there. And what do we want to do about that? Well, I'll talk about how we do it. Where we really want to get to is Windows isn't secured, Mac isn't secured, Linux isn't secure. There's no secured running environment that can't be attacked out there. So if we can move part of this application, theoretically, conceptually, to a trusted computing environment, or trusted execution environment that can't be attacked, then we're creating a much, much stronger link, and you can't just remove licensing.
Question?
Yep.
Are you referring that the trusted environment is all wired logic, rather than there's no Wi-Fi in between? Because Wi-Fi is the most insecure environment, which could be in some devices.
So when I talk about execution environment, I'm not talking about communication language. I'm talking about where does the algorithm actually execute? What is returning the result of your instruction set? Right?
So it is BYOD proof.
So give me a second and I'll get there in the slide. So the first step of what we do for engineering protection is, as I mentioned earlier, is we encrypt and obfuscate. Why do we encrypt and obfuscate? Because as your application is installed, it's open to reverse engineering. It's open to threats. So we want to obfuscate the instruction set. We want to obfuscate and encrypt so that somebody can't easily understand how your application behaves and makes changes to it. But once you load that application into memory, generally all that encryption and obfuscation goes away. The instruction set needs to be understood by Windows, right? So then we have to figure out, how do we ensure that no one is debugging, no one's tracing this application, what's going on? So we have a set of tools that prevent debugging and analysis, real-time analysis of what's going on with this application. And then back to, I think, to your question, which was, then we have this trusted execution environment. This can be a USB key for us. It can be the chip form factor, where we'll actually take portions of your source code, and instead of sending them to the operating environment to carry out the instruction and return the result, we actually send the encrypted instruction to essentially a virtual machine on our chip to be executed, and the token will only return the result, right? So this really creates the strongest absolute binding between a cryptographic source and the application that's running.
So do you disable the Wi-Fi on those computing devices?
Disable the Wi-Fi?
Yeah, because every laptop you show, any computer, computing device, these days come with Wi-Fi enablement.
Yes.
And how do you make sure you disable it before you do any of those functions? Because now, that being a Wi-Fi device, now data in what's called transit in the air
Yes.
is a vulnerable situation.
So you have an application running here, right? This application is connected to an environment that can talk externally, right? And I think what you're talking about is the vector of attack is somebody has an application running here and is sending communication out about what's happening here, right? A listening device, essentially. So what we're saying here is that because the code is actually executing in a trusted environment, you can't peer into the smart card chip. You can take an electronic microscope, but even the chips themselves that we use, they're like smart card chips, right? They have built-in protection against temperature, against electronic microscopy. So it's very, very difficult to understand what is executing inside here.
If I put another USB in the same device, when you're doing this, that USB can talk to the other USB, right?
Two USB devices can talk, but the application is only executed inside here. Okay, so that's securing the clients against reverse engineering protection. The last piece of securing the client is around the integrity, what I talked about before. I think everyone really knows what device integrity means. We all know this word. Application integrity, and of course we care about data and configuration integrity in the examples I gave before. So how do we get there? Well, first, we want to protect the boot. We want to make sure that the boot process has not been altered. All the boot applications have been validated against their integrity. No Trojan applications have been included in the boot process. That's the first step. Then we have to validate the integrity of the application itself and the data that's being used. Again, that data could be being used for you from a monetization standpoint. It could be configuration data. And lastly, as I said, in a connected world, you're going to constantly have updates. You don't want somebody to be able to figure out how to update your software and modify it without having the integrity of any update that goes to your device validated. You don't want to accept any updates that haven't been validated by the security system. So that's securing the clients. So now if we look at kind of the broader ecosystem and how do we secure that, there's three different areas, and maybe this gets more to your Wi-Fi question, is how do we secure communications in this ecosystem? How do we secure how my devices or machines are being built from contract manufacturers? Very few of us build in-house anymore, in the US anyways. It's true. And how do we secure a partner ecosystem? So the first, if we look at secure authentication and communications, we want to allow the client or device to have its own unique identity, right? User identity has been out in the industry for a long time. Machine identity has traditionally been a serial number. Well, it's not very hard, as we all know, to spoof a serial number. So we want to give a very strong, unique identity, cryptographic identity, to each and every device. And we want to use that secure identity as a factor of the secure communication. So how do we do that? So again, it goes back to taking this trusted source. In this trusted source, we have a smart card chip. We have cryptographic keys that identify itself as, hey, I'm uniquely, right? This is my secure onboarded ECC RSA asymmetric keys. And then we're going to expose those. We don't want to do anything proprietary, especially around communications. There's already communication industry standards, PKCS 11 and CAPI, which allow you, once you have those standards implemented on top of cryptographic keys, an ability to establish any SSL communication, any two PKI-enabled application in the industry, which there's a billion, are now supported. Okay, let's talk about contract manufacturing. So as I mentioned, the problem scope is very few of us build things in-house anymore. So how do I validate and control my volume manufacturer? How do I know that when Rolex goes and builds 10,000 watches in China, that they report 10,000 watches? Cool, great. But at the end of the day, they turn the lights back on and they make 10,000 more. But they don't tell me about them, and then they sell them to the black market, right? Or Hong Kong, or Taiwan, or wherever they sell it, Russia. So how do I prevent black marketed manufactured goods? This is a real hot topic from people I talk to. So as I mentioned before, we want to create a unique identity. We don't want to be spoofable. So we use cryptographic secrets to create that unique identity. Then we want to ensure that our volume manufacturers have a way, an easy way to report what they built. Why do I care about just the reporting aspect? Because when we're talking about this ecosystem, we're talking about devices that are connected to the outside world, this connected world, is we don't want the volume manufacturer to actually have a device that can be now used. We still want to essentially license this machine, and we're the only ones that can create the license. So even though that the chip is there, the identity is there, it's a dumb machine. It still doesn't have the license to do anything. So now once it's connected, your user buys the machine, you activate the license. Now the machine's fully functional. If, when this connection happens, you recognize, hey, this was a machine that wasn't reported to me, you know about it. You say, maybe I'll kill the machine. Maybe I'll follow up on who manufactured this machine. It gives you a lot of opportunity to understand how black market versions of your application are getting out there, your devices. Okay, securing the ecosystem. So as I mentioned earlier, we want to enable people to add value onto our ecosystems because that's how we do business. To do so securely, though, we want to be able to enable trusted partners to get on the client. How do we do that? And the security platform that we embed and use, that you guys would buy from us, we want you to be able to use that as core value so that your customers, those or your partners who are adding value on, can also enable security on their applications so that they're protected against reverse engineering. Somebody can't get in and control your device because they didn't do their due diligence on the security protocols. So how do we do that? Again, it always starts with a trusted source. I always recommend hardware because it's the most secure. We do have software versions. Then we talk about a chain of trust. How do I build that chain of trust? Tends to be through chain of trust of certificates. And then the core message here is we really want the security platform that you would integrate to be open to your partners so that they can leverage and protect their applications they're installing on your device so that there isn't a kind of a backdoor or a weakest link into compromising your applications. The most common question yeah.
So what are the implications for your third-party partners? Do they have to integrate the same capabilities or code into their system?
So it depends what you want, kind of. What we want to do is have this security system essentially be, as Darim talked about earlier, I don't know if he's in the room, is if you use, let's say, a USB key or a chip, right, embedded. So you have this strong, very strong container for a unique set of cryptographic secrets. So we want to be able to virtualize that into many containers, right? Each one having their unique, very distinguishable set of cryptographic secrets. Then being able to use those virtual containers to do things like reverse engineering protection, right? We have an envelope tool, a wrapper tool that provides these capabilities of static analysis, real-time analysis, the executing on the key, right? We want to provide those capabilities to protect those software running. So yes, it's essentially exposing those tools that would secure, leveraging the hardware investment or the licensing platform investment that you've made into the device.
So the third party would have to invest in that themselves.
So yeah, to a certain extent, right? You have to do something. It's not like free, right? Except for in the case of secure communications, they can leverage, right? Because it's an open standard, as long as you've integrated the standard, then it's usable right out of the box. This is my last slide, and then any questions. So the most common question I get asked as a product manager Why can't I do all this myself? I have software engineers. I have hardware engineers. Why? Why do I need Gemalto? Why do I need a partner? Well, it's okay. You can. We can all build everything. There's no problem. However, there's 5 points and 2 that I really want to stress. The first is security is really an ever-changing game. It's always evolving. So it's all about investment. How much do you want to invest? And it's not a today investment. It's an ongoing investment, right? And it's an investment not just in technology. It's not just the platform. It's also a skill set investment. You need to continually train your teams to become security experts. And every year, as we all read the news, it's an arms race against cracking tools. There are new threats every year. Every 3 months, there's a new exploit. There's a new patch. There's a new way to get around. You have to always be monitoring and reacting. So do you want to focus and invest a team just to do that? You can. It's okay. However, one of the things that I often get brought into is security expertise can be a scarce resource, right? I can't tell you how many clients of ours have come to us and say, we knew one person who knew the licensing system, and they left. We don't know what to do now. Okay, so if you do it yourself, you have to have your own redundancy. If you have a partner, we have the redundancy built in for you. You need to know the right tools for the right problem, right? Encryption doesn't solve data integrity. You can't just encrypt everything and say, I'm secure. You have to really understand the security ecosystem. But this 4th one, is really the key for me, which is if you are focusing and investing in a team against security, you're not investing in the core value or your competitive edge against your competitors. So why? It's kind of a waste of time for you. So it's generally much cheaper to go with a partner like Gemalto than to do it yourself. And then lastly, of course, get to market much more quickly with off-the-shelf than having to build anything from a security platform. Okay, I only had 30 minutes, and I could have probably taken 30 minutes for each slide. So,
question.
Please.
The USB that you give to your customers, actual device that you give, what do you do when you buy the USB from wherever source you have? A company which makes USBs. Do you buy regular USB which is in the market?
Us? You're asking if we buy?
When you sell to someone, right? You give the device.
Yes.
The trusted device, as you call it. It's a USB device or a chip, little chip, right? And that device itself, is it off the shelf?
No, not at all. By the time our customer gets the device, we have a personalization step that happens. That personalization step initializes essentially a set of cryptographic secrets inside that key that only you have, right, as a customer.
The device itself, the hardware.
Sorry to stop this. It's just that we're in break mode, I think, and we're being pushed to this.
Okay, no problem.
Okay.
We'll talk offline.
Yeah, we can talk right now after. Okay, so we're done. Thanks, everyone.
You can just grab Todd.
Yeah, grab me, thanks. That's great.